Okay, yesterday we studied about all four theories, and today actually I thought to teach you about the plate tectonic theory, but today we'll be studying about universe, solar system, and all the planets, latitude and longitude. Then after that we'll see about that interior of the earth, then all that forces of the earth. Then after that we'll see about the plate tectonic theory, because that is the last syllabus in geomorphology. Then after plate tectonic theory we'll study about all those formation of mountains, then river landforms, erosional landforms, then wind landforms, glacial landforms, that we'll study in the last. So can anyone confirm me whether my screen is visible to or not?
Yes, sir. Visible, sir.
Okay. So we'll start now. First, we'll start our session. If other person wants to join, they can join in the middle. First, we'll see about the universe. Sorry, actually, I should have taught you this about universe, solar system at the start itself, because from universe, solar system, and planet, one question have come in the 2023 second paper. So this time 2024 we are expecting one or two questions from the universe, solar system, or planet. So for that only I have brought you this topic. Before it was not that much important, but since it has been asked in the last paper, so we will study about this also, and we will study into the depth, so that all your concepts and everything is clear. Then after that, if you try to solve any questions, you can attend it. So we'll study in depth. So universe. So first see how universe found, how we were able to know about all this. This was all because of Big Bang theory. So that was in Big Bang theory. What happened? There was a huge amount of explosion. Then in that only some particles solidified. Then that particles came to be known as universe. So the universe comprises billions of galaxies, and universe comprises of, see, you can see here. Suppose if this is the universe, so this is a full universe. Now in full universe, see, this one is full important of part of all those like galaxy, planets, and solar system, everything. So this is super group. So that universe is a super cluster. Then from that cluster, if you see that a smaller part, that is local group, this is part of galaxy. Then inside that galaxy, we are the family of Milky Way galaxy. So we are in the Milky Way galaxy. Then inside Milky Way galaxy, we have many stars. In that, one of that sun also there. So in that solar system also there, and in the solar system sun is there, and in sun we have our planet Earth. So this one full is known as universe, cluster of everything, galaxy, star, solar system. So see here, universe comprises billions of galaxies. A galaxy is a giant assembly of stars, planets, gases, and dust. Our galaxy is named as the Milky Way. So we are in the Milky Way galaxy, and it contains about 300 billion stars, and one of those is our sun. So inside galaxy, see, inside this galaxy we have that star, that is sun. So in that in galaxy we have the solar system, and inside solar system we have the sun. So see, planets and other objects go around the sun and make up the solar system with the sun at the center. And nearest galaxy, we are in the Milky Way galaxy, and nearest galaxy to Milky Way galaxy is Andromeda. So remember about Andromeda galaxy. So the nearest galaxy is Andromeda, and nearest star, if they ask, that is Proxima Centauri. That we will study in later part also. Okay. Now see, how old is the universe? So universe is 13.7 billion years old. So in that before 13.7 years, that time that universe was in fully molten state, and there were a lot of many dust and everything was there. Then after cooling down, then that time universe got evolved, that is 13.7 billion years ago. It all began with Great Bang. So that you must know about the Big Bang theory, a kind of explosion that not only produced all the matter, all of the matter in the universe, but also signal the beginning of time. So currently the universe is thought to contain roughly 100 billion galaxies, each with an average of 100 billion stars. So the Milky Way galaxy, on the other hand, is thought to have between 100 to 400 billion stars. So that Milky Way age is that 100 to 400 billion stars. Okay. Now some important terms were given. In ancient age, that time there were many scholars. They gave some terms. Say in AD 140, Ptolemy propounded the theory that Earth was at the center of the universe. So Ptolemy first proposed that Earth was at the center, but in 1543, Copernicus said that Sun is the center of the universe, not the Earth. And Ptolemy also said that Earth is at the center of the universe and Sun and the other heavenly bodies. But Copernicus said what? Sun is the center of universe. So you must know that who said that the Sun is the center of the universe, not the Earth. So that is Copernicus. And if questions comes, who said that Earth is at the center of the universe? That is Ptolemy. But in Copernicus' proposal, in that Kepler added something. He supported and he added that he said that Sun is at the center of solar system, not the universe. Copernicus said that Sun is at the center of universe, but this Kepler said that Sun is the center of solar system, not the universe. Then in 1924, in modern era, Edwin Hubble, he first demonstrated the existence of galaxy beyond Milky Way. So he demonstrated about the Milky Way galaxy. Okay. So we study about Ptolemy, Copernicus and Edwin Hubble. Now see, galaxy. See, galaxy, all these are in a spiral part or it's moving in elliptical orbit and they are in irregular shape. They don't have any shape. Structurally, the galaxies are found in three forms. A spiral has central nucleus with great spiral arms. The Milky Way and Andromeda are examples of it. And they have the elliptical without a spiral arms. They don't have any arms and they have elliptical shape. So they are moving in elliptical type. So it's in elliptical. Elliptical means what? It's not full circle. It's like this. So it's not in full circle and it will be bulging towards like at the center. If you see, if you take this one, so that will be bulging. So that is elliptical. So they are elliptical without a spiral. Okay. Now Milky Way galaxy. So Milky Way galaxy, we are in the Milky Way galaxy. So a galaxy is defined as a large group of star, gas and dust bound together by gravity. So universe have the gravitational force. So that galaxy, they are defined as a large group of stars, gas and dust that are bound together by gravitational force. Our galaxy is Milky Way because it appears as milky band of light in the sky, and galaxy come in a variety of shapes and size. So Milky Way is a large band spiral galaxy. Now see, in Milky Way galaxy we have the solar system, and see in Milky Way galaxy we have one arm that is known as Orion spur. So this Orion spur is arm. So this arm, in that arm, our solar system is located. So Milky Way galaxy has an arm that is Orion spur, and in that Orion spur, so our solar system is located. In ancient India, it was imagined to be a river of light flowing in the sky. So in ancient time, it was imagined as a river of light flowing in the sky. So thus it was named as Akash Ganga. So this is a Hindi name, that is Akash Ganga. So see, here our nearest in that solar system, we in this Milky Way galaxy we have lot of stars. In that lot of stars we have our solar system, Sun, and nearest to Sun there is a star that is Proxima Centauri. So that is nearest from the Sun. So if questions comes which star is nearest to Earth or nearest to Sun, that is Proxima Centauri. Okay. Now see, this was the Big Bang theory. First it was like fully a ball, like a ball of fire. So after it exploded and it cooled down. So after cooling down, it started forming into the universe. Then after that, there were a lot of frictional force and gravitational force. So due to collision, they started breaking into parts. Then after that formation of stars, dust, and galaxy that took place. So at the end, see, expansion of universe begins to accelerate. That is few billions ago. That means we study in the first part, that is 13.7 billion years ago. That time universe was evolved. Okay. Now in the galaxy we have our solar system. So we'll study about the solar system. The solar system is a gravitationally bound system of the sun and the objects that orbit it. So either directly or indirectly. See what's happening. See here, suppose if this is the galaxy, so in this galaxy they have a large amount of gravitational force. So they were acting as a induced magnet. And also in our solar system also, that inside sun we have the induced magnet. So if due to that one, what happened, that if other particles like dust or anything, or meteors or heavy metals which can destroy our solar system or destroy our earth, that were coming, that were sent away due to gravitational force of the sun. So that was that centrifugal force of the sun or earth, and also gravitational force. See, our solar system consists of our star, sun, and everything bound to it by gravity. So everything are bound by gravity. The planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And there are many dwarf planets also, and one is that Pluto. Before 2010, we were studying that Pluto is a planet, but after that, it was decided that now we can call it as Pluto as a dwarf planet. Why? Because it was going to Earth's orbit and it was revolving around the sun. So they declare it as a dwarf planet. The solar system formed around, universe formed around 13.7 billion years ago, and our solar system formed around 4.6 billion years ago from the gravitational collapse of a giant interstellar molecular cloud. So that molecular cloud, interstellar molecular cloud, that collapse happened, then in that solar system were formed from that. Okay. Now see, due to sun's gravitational force, here you can see 8 planets are revolving around it. So due to that gravitational force, see, sun is like you can take it as circle only, but it's very huge. So around it has a large amount of gravitational force. So due to it is attracting other planets and other things which are near to the sun. Like it is attracting planets, then dwarf planets, moons, comets, and asteroids. So what is happening? And since other things also, they also have their own gravitational force, so they are revolving around the sun. So due to sun's gravity, we have the 8 planets in the solar system, dozens of dwarf planets, 170 moons, comets, and also we have the comets and asteroids. And see, a star is if we study about this one, a star is an astronomical object comprising a luminous spread of plasma held together by its gravity. So that is held by the gravity. And fourth state of matter, that is plasma. So inside sun we have the hydrogen. The 2 hydrogen bonds are joining and they're fusing and they're making as helium. So inside that sun is like a fireball. So due to that other fourth stage of matter is taking place, that is known as plasma. So that stars, they are composed largely of gas and plasma. Superheated states of matter composed of subatomic particles. Stars were formed when the galaxies were formed during the Big Bang. And stars, they have the cosmic energy engines that produce heat, light, ultraviolet rays, X-rays, and other forms of radiation. And see, this star, that sun has a temperature of 600 degrees Celsius, and it is 109 times bigger than Earth. So it is 109 times bigger than Earth, and it has diameter of 14 lakhs kilometers. So it has a diameter of 14 lakhs kilometers. Okay. Now before studying about the planets, we'll study about the constellation, that all other stars. See, there are many stars, and remember about all these important stars names because it has been asked in the both CDS and FCAT exam. So remember the stars names. Thousands of stars appear in the sky during the night. So some of these form a pattern in a group which have recognizable shapes. So this group of stars is called as constellation. So in that constellation also we have the Saptarishi. Saptarishi, you know, that arrangement of stars, that 7 arrangement of stars, that is Sapt means 7. So 7. So at present there are about 88 constellations. Each constellation has been given a name according to its shape. So according to their shape, their name is given. You know, all these stars, they are on the name of zodiac signs. You all say about all your zodiac signs. So all those stars on the name of zodiac sign. So some of the important constellations are Ursa Major, Ursa Minor, Orion, Leo Major, and Cassiopeia. So remember about these important names because these are not in the names of zodiac sign. Others all are the zodiac sign. This arrangement of stars there, and they have their shape. So that shape is on the name of zodiac sign. So easily that one is that everything you can remember. But these names are not there in that. So remember all these names. So they might give options for this, and they might ask which one is not in the constellation or which one is not a star. So remember these names: Ursa Major, Ursa Minor, Orion, Leo Major, and Cassiopeia. Okay. Now we'll study about the sun. So see inside how is sun is producing energy, or why sun is known as ball of fire, because see inside sun we have the presence of large amount of hydrogen, so that they are colliding, they are forming bond, and they are coming to helium. So that due to fusion of these hydrogen bonds they are producing large amount of energy. So that large amount of energy, see that is we are knowing that sun has a temperature of 6,000 degree Celsius, 6,000 degree Celsius. But what is happening inside? This is the outer surface temperature, but inside this earth, inside this, at the center of the sun, we have more than 15,000 degree Celsius temperature. We have more than 50,000 degree Celsius temperature. So that we are studying that only about the outer temperature, outer surface temperature. So inside at the center we have above 15,000 degrees Celsius. So in a star made up of extremely hot gases, particularly by hydrogen. So this sun is made up of hydrogen, 70% hydrogen is there. Then helium is 26.5%, and some other gases are there. They are 3.5%. So it is 109 times bigger than the Earth and weighs. No need to study about the weight, but a study about the how much time it is bigger than the Earth. So it is 109 times bigger than the Earth, and it accounts of 99.83% of the mass of the solar system. See, inside solar system we studied here. We studied that there are we studied here that there are 8 planets, dozens of dwarf planets, 170 moons, comets, and asteroids. But these are only like 0.5% mass. See, totally 99.83. So that all that dwarf planet and moons, comets, and asteroids, planets, they are accounting only 0.17% of the mass of solar system. But overall, totally 99.83% of the mass of solar system is sun. So that sun is covering 99.83% of the mass of solar system, and it is 150 million kilometer away from the Earth. And sunlight, so that sun is 150 million kilometer away from the Earth. And you know, distance from the sun, there are two terms, that is aphelion and perihelion. So perihelion, so see this perihelion, that is the shortest distance from the Earth, and aphelion is known as the longest distance from the Earth. So that things we have studied inside the FCAT time. So that slide also I'll share to you. So a study from that slide also. If some syllabus are left, a study from that slides also and a study from this slide also. Then your whole syllabus about solar system, universe, and planets, everything will be clear. So today we'll study. If some syllabus is not there, then go through that slide also. So our Earth is 150 million kilometers away from the Earth. That aphelion and perihelion is not mentioned here, but see in that slide, which I will share in the group. And sunlight takes 8 minutes to reach the Earth's surface. So how much time it takes the sunlight to reach the Earth's surface? That is 8 minutes. And it has our sun, solar system. Inside solar system, we have sun. And sun have a large amount of gravitational pulls. So which keeps the planets fixed in their orbit, revolving around the sun. So it continuously gives off energy in the form of visible light. So see, inside that two hydrogen bonds are joining. So inside the solar system, we have due to that fusion of hydrogen bonds, we have the large amount of energy. They are emitting large amount of energy in the form of light, infrared, ultraviolet, X-rays, gamma rays, radio waves, and plasma gas. So this all about this light, infrared, ultraviolet rays. All this you will be studying in physics also. And if we have time, we'll study in this class also. Now see, suppose now take this as a sun. So sun, this is very fiery in nature because of fusion of those hydrogen. So that fusion, because of that fusion, it is emitting large amount of energy. So that is fiery in nature, and it has large amount of gravitational pull. So this, see, actually due to the gravitational pull of sun only, we are safe from the all those meteors or asteroid or dust coming from the universe. So due to that only we are safe. So due to gravitational force, and also the centrifugal force which is sending them away or just burning them. So due to that we are safe. And sun has a large amount of magnetic field. So because of gravitational pull and magnetic field, all planets, satellites, and everything are revolving around the sun. Now see here. Sun has large amount of magnetic field. You can see a large amount of magnetic field is there, and this is caused by plasma, because these pushing particles, they are pushing the particles towards poles. So inside this there is large amount of explosion. So that is caused by plasma. So that they are pushing all the particles towards poles. So they are pushing it away. And this outer surface of these magnetic fields, that is known as heliosphere. Outer surface of magnetic field of solar sun, that is known as heliosphere. So remember about the heliosphere name. Okay. Now we will study about the layers of the earth. So layers of the earth question have come. So you must know all the layers of the earth. We have inside this sun, we have inner layer, and also we have outer layer. And question have come about the outermost layer. So we'll see about all layers. So inside this sun solar system, we have inner layer, that is known as core. So see, inside this, at the center of solar system, I said you that it has high temperature, like above 15,000. See here 15 crore this Kelvin says it has the amount of energy. Then inside the radiative zone, we have like 70 lakhs Kelvin. Then in convection zone, we have 2 lakhs Kelvin. So inside these are the core, radiative zone, and convection zone. They are the inner layer of the sun. And outer layer are photosphere, chromosphere. Then this is the transition region. Then after that we have the corona. So this corona is the outer layer. We'll study about all these layers separately. Now we'll study here. So see, inside sun, due to that explosion and due to that bonding, due to fusion, it is producing large amount of flare. So this flare we will study about the dark spot also, sunspot, dark spot. So where we see these flares, they are known as spots. So due to this, some other places there will be some darkness. So that is known as dark spots. So that will see in this also. Now see. Now we will see about all the layers of the sun. So core is the centermost region. We studied that at the center we have the core. The centermost region of the sun is known as core, and this region where hydrogen turns into helium. So at the center only that hydrogen, that fusion is taking place. So hydrogen turns into helium through the nuclear fission reaction, with temperature believed to be reaching more than 15 million degrees Celsius. So the core is considered to be the hottest region of the earth. So if questions comes, which is the hottest region of the earth, that is core. And inside this core we have the 91% hydrogen and only we have 8.9% helium. So that hydrogen turning into helium due to fusion, nuclear fusion reaction. When we move towards outward layers, the density and temperature decreases. So as I said that we have at the outer surface we have only 6000 degrees Celsius. So as we are moving out of the outward layers, so that density and temperature are decreasing. And at the center of the core, it is about the density is 150 gram per centimeter cube. So remember about the temperature outer surface, that is 6000 degree Celsius. Okay, now second layer. This core is the inner layer. Then second layer again radiative zone. This is also the inner layer. Totally we have 6 layers. So inside that we have divided that inner layer and outer layer. In inner layer we have core, then we have radiation zone, and we have convection zone. So now we will study about the radiative zone. Between the core and convection zone, there lies the radiative zone. So by means of radiative diffusion and thermal conduction, the energy in this layer transports outside. So by means of radiative diffusion. So why this temperature is decreasing as you go outwards? That is due to the radiative diffusion. So the energy in this layer transports outside. They are transporting. So not all amounts of energy is transporting. So it's going on decreasing. So which travels in the form of electromagnetic radiation by photons. So that all those energy are traveling in the form of electromagnetic radiation by photons. Now we'll study about the third zone, that is convection zone. So convection zone, this is the outermost layer of the sun's interior. So that is known as the convection zone. So in the inner layer, outermost is the convection zone. So this zone uses the convection mode to transfer energy. So we studied about that convectional current theory. So in that same like convectional current theory, we studied that it will start diffusing energy outwards. So only some amounts of energy will escape. So we studied that some amounts of energy will escape. So that only this zone uses convection mode to transfer energy, and other amounts of energy which are not able to escape, then again they will turn back to there at the center. So that temperature at its base is about 2 million degrees Celsius. Then the next zone is in the outermost, in the outer layer we are coming. In the outer layer, first zone is photosphere. So remember about the question that outermost layer, if question comes, then that is corona. So don't get confused with the photosphere, because everyone will be thinking that photosphere it is inside the sun, and if they are not knowing about the corona, so they'll mark the photosphere. So don't get confused with that one. The photosphere has a thickness of about 500 kilometer, and all the visible light from the sun comes from this layer only. So all those visible light we are receiving on the earth, so that is from the photosphere. So remember about this question and answer. So all those visible light we are receiving from the sun, that is from the photosphere part of the sun. So with temperature coming down to approximately 500 degrees Celsius, it is said, and photosphere is said to be the coolest part of the sun, because as we go increasing height, that temperature drops. So the phenomena sunspots happen in the photosphere. So that sunspots phenomena is taking place in the photosphere. Okay, inside that sunspots we are finding it in photosphere. So we'll study about the sunspot also. So the dark spots on the surface of the sun are known as sunspots. So this happens because what happens in this area, in the photosphere region, that it is cooling down. And why it is cooling down? Because the region has become darker and cooler than the surroundings. So that it has become darker and cooler than the surroundings. So due to intense magnetic fields on the surface, so we are finding the sunspots. So we have named it as the sunspots. See here this spot. This is known as sunspot. This darker, this white one. So this is sunspot because due to the cooler surrounding and darker. So due to that intense magnetic field, it has become cooler and darker. So that spot is known as sunspot. The lifetime of sunspots is generally less. So sunspots that will be visible only once in 11 years. That sunspot that will be visible only once in 11 years. So remember about that sunspots will be able to see in once in 11 years. So the lifetime that it is generally less. So it fluctuates from a few days to a few months. So what will happen? After 11 years again it will start fluctuating, then after that again. So umbra is named at the center of sunspot. So if this is the sunspot, then center is known as umbra and penumbra is known as the lighter region of the surrounding. So all those lighter regions surrounding is known as penumbra. Now you can see here in this one. See, this is the sunspot. This full thing is sunspot. So in that, see, this darker region is the center is the umbra, and this lighter one is the penumbra. So this is about the sunspot. Now we will study about the fifth layer of the sun, that is chromosphere. So that chromosphere is visible as a dim red ring, and it lies just above the photosphere. So for that visible light we are receiving from the sun, that is from the photosphere, not the chromosphere. So only that eclipses and that everything we are seeing, that is chromosphere. So only during the solar eclipse, when the photosphere is hidden, visible light from the chromosphere can be seen. So remember about this phenomena. See, we are receiving that light from the sun. We are receiving light from the sun from photosphere. We are receiving from the photosphere. But during the solar eclipse, what happens? Suddenly it becomes dark. So when the photosphere is hidden, photosphere is hidden, that visible light will see that is from the chromosphere. So with an increase in height, its temperature increases. So in photosphere, what is happening? With increase in height, we are having temperature decreasing. So that temperature is decreasing in photosphere, but in chromosphere it is increasing. So that similar things can be seen in the Earth's atmosphere also. So that we will study when we will study about the climatology. Okay, now the last and the outermost part is the corona. So the coronal layer is the outermost layer of the sun's atmosphere, and it lies above the chromosphere. So during a total solar eclipse, it can be seen as a white glowing corona. So see, we study about this chromosphere. So that visible light, that dim red ring, that we are seeing, that is chromosphere. So during the solar eclipse, if you are seeing the visible light, that dim red ring, so that is chromosphere. And whereas that during solar eclipse also only we will be able to see corona also. So that is it during a solar eclipse, it can be seen as a white glowing corona. So that solar eclipse, when we will see that dim red ring, that is corona sphere. In that only, nearby that, if you see that white one, so that white glowing, that is corona. So up to 2 million degrees Celsius, the temperature on the corona spreads, and the reason for it is still unknown. So coronal mass injection, solar winds, and solar flares are the phenomena related to corona. So all those solar flares, solar winds, and coronal mass injection, they are phenomena related to corona. Okay, this was about the sun. So we study everything about sun and universe. So now we will study about the planets. So in solar system we study about the sun. Now we will study about the planets. So planets means wanderers. Everyone knows that we have 8 planets. Before it was 9 planets, but Pluto was declared as a dwarf planet. So now we have the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And all those planets move around the sun in a fixed orbit. So that orbit is elliptical. That orbit is in elliptical manner. So that is not circle or pure circle or sphere. That is in elliptical manner. So they are moving around in the elliptical orbit. And already we studied that how all those are revolving around the sun. That is due to gravitational pull and magnetic field of the sun. So due to gravitational pull and magnetic field of the sun, all planets are revolving around the sun. So see, our solar system, all those are revolving around the sun in the elliptical orbit. And see, after first 4 planets, that first planet we can see Mercury, that is nearest planet. Then we have Venus, then we have our Earth, then Mars. Then there is a belt, that many dust particles are there, that is known as asteroid belt. And after the asteroid belt, we have the gaseous planets. All these planets are known as terrestrial planets, and all these planets are known as gaseous planets, that is Jovian planets. So these planets are made up of gases. All those planets outside of asteroid belts, they are the outer planets. They are made up of gases. They are made up of gases. Whereas all these planets, they are made up of rocks or dust. Means solid things are there. So they are made up of rocks. Whereas these planets are made up of gases, outer planets. Okay, now see, the planets are grouped into 2. So that we studied already. That first one is terrestrial planets. So these are dense rocky bodies. So see what happened when that explosion took place. So in that, what happened from the sun, after see what will happen. Now explosion taking place. So from the sun, if that all those particles and everything are coming down, then those particles will be somewhere nearby to it, and then that gas. So gas, you know that gas can means it can occupy any places, and that gas, if that whole full amount of energy is produced, so they might fly somewhere. So that's why they are in the outer planets, and all those rocky planets are in the nearby. So through this way you can remember that if that solid parts are there, so that will be somewhere nearby, and if gas is there, then gas, they will fly, means they will be in the outer side. So through this, in case you can remember that inside the asteroid world we have the terrestrial planet. They are known as dense rocky bodies, and the outside we have the Jovian planets. They are known as the gaseous planets. So dense rocky bodies about terrestrial planets. So the dense rocky bodies and are called as Earth-like planets. So we have Mercury, Venus, Earth, and Mars. So terrestrial planets are Mercury, Venus, Earth, and Mars, and they are also known as inner planets. Jovian planets, they are the outer planets. They are in very weak sizes. So they are in gigantic sizes and are gaseous in composition, with large satellites are called as Jovian planets. So they have similar features of that Jupiter. So thus Jupiter-like planets. So they have the mostly they have the similar features. Like you can see that they have large amount of satellites. You can see that there are large amount of satellites that like moons. Then since and also you can see formation of rings. So that also can be seen in the Jovian planets. And whereas in this terrestrial planet, you will be able to see no moons or less moons. Like Venus and Mercury, they have no moons. Whereas Earth, we have only one, that is moon, and Mars have only 2, that is Phobos and Deimos. So that also we'll study, we'll see in later part. Okay. So now about the first planet we'll study, that is Mercury. So Mercury is the smallest planet in our solar system. So Mercury is the smallest planet and it is nearest to the Sun. So this planet is only slightly larger than the Earth's moon. It is closest planet to the Sun at a distance of 58 million kilometers. So that is 0.39 astronomical units. So see, now since we are studying about planets and Sun, so you must know about the revolution and rotation, because now we will be seeing all those. See, suppose if you take mostly all those planets, everything they are in a elliptical, or you can say spherical. So here see, suppose if they rotate, now take this as one axis and this is this as their axis. Now you can take it an example of globe. If you take example of globe, so once when they are rotating on their axis, now this is their axis, so they are rotating on this itself, so that is known as rotation. So they are rotating on their axis itself, so that is rotation. And now suppose if there is a Sun and they are moving in an orbit, see, on its space itself, if they are rotating on their space itself, that is rotation. And if they are traveling from here, like suppose if they are traveling here, so, and from here if they travel here, so that is known as revolution. So now since we are studying about the planets, so we will be studying about all those revolution period and rotation period. So now we must not confuse with revolution or rotation. So Mercury is the smallest planet. We studied. See, 1 day on Mars takes 59 Earth days. So that rotation on its axis, once they are rotating, suppose if Mercury is rotating on its axis, so it comes to its original place, that is 59 Earth days. That means 59 days. So its rotational period is 59 days. And Mercury is the rocky planet, also known as, so that we have seen in the types of planet. So it takes 59 days for rotation. But where is it to rotate around the Sun, to revolve around the Sun, it takes about 88 days. So this is Mercury revolutionary period, this is Venus revolutionary period, this is Earth revolutionary period, this is Mars, this is Jupiter, then we have Saturn, then we have Uranus, this is Neptune. So this revolution period of all those planets is given here. So revolution period of Mercury is 88 days. So it's revolving around the Sun. Suppose if this is the Sun, it's revolving around the Sun in 88 days. Now it is at this place. So after 88 days revolving around the Sun, it will come to its original place. So like in Earth, we have a year as 365 days. 365 days. Our Earth is revolving around the Sun, in 365 days, 6 hours. So that's why after 4 years we have 366 days. This 6 hours is added. So that 6 into 4 we get 24 hours. So revolution period of Earth is 366 days. So we have 1 year. So now in this Mercury part, that 1 year is 88 days. In Earth we have 365 days. So in Earth we have that 1 year is 365 days, but whereas Mercury, if we consider it as, then we have 1 year is 88 days. So remember about the revolution period of Mercury, that is 88 days. Now see, we'll see the why this Mercury. Now this Mercury will see the inner parts, that core part we'll see. See why there is no life, no existence of life, because see inside the inner part, during the daytime, when that Sun is facing at the head of Mercury, so during the daytime we have this temperature as 427 degrees Celsius. We know that now even at the Earth we are not able to survive even 55 degree, or you can say 45 degree, we are not able to survive. So how come at the 427 degree we can survive? So there is no existence of life because of high temperature in the daytime. Whereas in the night time we have, when that Venus axis is not towards the sun's light. So that time we have the minus 179 degrees Celsius. So that time in night time it becomes colder, and in daytime it becomes hotter. So due to that there is no existence of light. So see, now day by day, due to that mercury is shrinking. Suppose see, now since it is near to the sun and it is not fully rock particle, it is rock particle, but it is in molten state. So day by day, after sometimes due to that heat, if that will start becoming solid, fully solid. So due to that energy, it is shrinking day by day. So it becoming less. So that iron core inside that, it is fully that made up of iron. That 85% if you see, that is fully iron, but that is molten iron. So that iron core, that is getting cooled. So due to cooling, it is sinking day by day. So it is that absorbing all those outer particles. So that is pulling the surface. So that pulling the surface inwards. So mercury is shrinking day by day. See, now we'll see the outer. Now inner part we had seen about the core of mercury. Now we'll see the outer part. Outer part, that is exosphere. So see, similarly how we have in our Earth atmosphere, we have all those layers, that troposphere, stratosphere, then stratosphere, we have mesosphere, and at the end outer sphere, thermosphere also we have. Then at the end outer sphere we have exosphere. So this mercury, that is located only in the outer exosphere. They also have that atmosphere, so they're located in the outer exosphere. So that exosphere is a thin layer. Their layer is thin layer, and it consists of oxygen, sodium, hydrogen, helium, potassium. So remember about all those gases named. Even though they have oxygen, but due to that large amount of heat, that hottest, and due to large amount of cooling down, we don't have the existence of life over the mercury. And remember about the spacecraft. We will be also seeing in all these slides about the spacecraft of all the planets. So only two spacecrafts were sent to the Mercury by NASA. No other agency, like in India we have ISRO. So no other agency have sent the spacecrafts. So only two have been gone to Mercury. That is, one is Mariner 10 in 1973 and Messenger in 2004, and they were sent by NASA. So remember about these spacecrafts names, and remember all spacecrafts name of all the planets except Earth, because you know that in Earth we have sent many planets. So that current plus your study about Earth, but in all other planets we have only little amount of spacecraft that they have gone to their atmosphere. So remember about all the spacecraft's name. So on the Mercury we have Mariner 10 that were sent in 1973, and we have the Messenger 2004. Both were sent by the NASA. Okay, now we will see about the Venus. So Venus is the 6th largest planet, and Venus is the brightest planet. If this is not marked, just remember Venus is the brightest planet, and we also call this Venus as the morning and evening star. So remember about this one, morning and evening star. So remember about this one. So we call Venus as morning and evening star also. This one is the brightest planet, and even when how we are able to know that whether that is Venus or not. So in morning, if you go outside, if you go towards the north, you'll see something shining. So that is the Venus planet. So that is the brightest. Venus is the brightest planet. It is like same as brightest as sun and moon. So after sun bright and moon bright, we have the Venus. So it is the brightest planet in the solar system. So Venus is only little smaller than the Earth, and Venus is second closest to the Sun at a distance of about 108 kilometers. So that is 0.72 astronomical unit. And so 1 day on Venus, take it as 243 days. So that is rotational period is 243 days. It takes for Venus to rotate or spin once. Venus is a rocky planet, also known as terrestrial planet. Venus solid surface is created an volcanic landscape. So on Venus also we have the volcano. So see, this Venus is also known as Earth's twin. Venus is also known as Earth's twin. And why this Venus is known as Earth's twin? We'll study when we'll study in the later part. Why it is known as Earth twin? Because it has same all the features that we have on Earth. But here life is not possible because due to that large amount of heat. That we'll see. This is the hot. Even though Mercury is the nearest planet to the Sun, but Venus is the hottest planet. So that also we will see later. Venus, it has a thick and toxic atmosphere that is made of carbon dioxide, CO2, that is nitrogen, with clouds of sulfuric acid. So about this only question has come. If you see the 2023 second cdse paper, in that question has come about that carbon dioxide, nitrogen, and about sulfuric droplets. So that's why we are studying this solar system. So see this. Venus has thick and toxic atmosphere that is made up of carbon dioxide, nitrogen, and clouds of sulfuric acid droplets. Okay, now we'll see the Venus parts. So in Venus, we have the same, like, see, why it is known as Earth's twin? Because see, we have core, mantle, crust. So interior, we have the core, mantle, crust. So inner that core is iron. Even in Earth also we have inside. See, Earth part, if we go that crust, we in Earth we have seema that is made up of silicon and magnesium. Then, sorry, that is made up of silicon and aluminum, that upper part crust. Then we have mantle. We have mantle that is seema, silicon and magnesium. Then inside we have Nephe. Inside the core we have Nephe, nickel and ferrous. So see, that ferrous, that iron, inside the earth, iron is present, and even in the center of core of Venus, we have presence of iron. So this is also one of the reasons for the Venus to be known as Earth's twin. Then we have hot mantle, then rocky crust is there. Then see, Venus, it is, see, why, one more reason we'll see why it is known as Earth's twin. See, radius, it has 95% of Earth. So that is also one of the reasons. Then mass, 87% of Earth. Then density, same, 91% of. Then gravity, 90% of Earth. So this is also reason for the Venus to be known as Earth's twin. Then on Venus we have a volcano. There had been the volcanic eruption. So due to that volcanic eruption, we have the largest volcano, and that largest volcano has the highest peak. That volcano is known as Maxwell Montes. Remember this name, Maxwell Montes, and it has the same height of Mount Everest. So it is same higher like Mount Everest. That is 8,848 meter. So on Venus we have the volcano that is Maxwell Montes. And see, why Venus is known as this hottest planet? Because in daytime we have 471 degrees Celsius temperature. So that's why this is known as the hottest planet. And why it is hot? Because see, on the surface of Venus we have greenhouse gases, that is CO2, methane. All those greenhouse gases are present on the surface of Venus. So they are absorbing, that greenhouse gases are absorbing CO2. So due to that only they have they are known as the hottest planet of the Earth. And why this we are not able, there is no existence of life on the Venus planet? That is because because it has the very high pressure. See, if we inside the ocean or inside the sea, if we go, so we have the high pressure. After that limit of that high pressure, if we go inside, more deeper inside the sea, then we'll burst. So that high pressure on the Venus, that is 90 times. So 90 times pressure that inside the sea level, more than that 90 times that pressure there on the Venus. So see, if you go on the Venus, you will be like burst, parts will be blown here and there. So that's why there is no existence of life on the planet Venus. So only two spacecraft had been sent to the Venus. That is Venera 91. That is by the USSR. Then another is Venera 13. That is also, both are sent by the USSR, Venera 91 and Venera 13. So remember about these spacecraft, and on Mercury we studied about that Mariner 10 and about Messenger. So I studied about that one also. Okay, now see. Now this on the surface of Venus, like if we go above 30 meter, so if you go at the height of 30 meter, then that same everything are like Earth. So if you go above 30 in the atmosphere of the 30 meter of the Venus, so that all those things are available same as Earth. So in the ancient, in the very old times, in million years ago, there was a presence of life. So there was a presence of life, that is microbial life, that microbes. So that microbial lives were present in the very old times. So because of all those regions, this Venus is known as Earth's twin. So now we'll study about the Earth. So about Earth, interior of the Earth and all other parts, climatology, oceanography, everything we'll study in the other part. So only that some important information we'll study now in this class. So Earth is the third planet that everyone know, and this is in the Glody load zone. So Glody load means that is life presence zone. So this is also known as Glody load zone. So this rotational period is 24 hours, that we call it as day. You know, Earth's atmosphere is 78% nitrogen, 21% oxygen, and 1% is some other ingredients like carbon dioxide, monoxide, then argon, all other gases. So Earth has only one moon, and that is the natural satellite. So about Earth, I hope so everyone know about the Earth. And see, in modern Earth we have about inner core, outer core, mantle crust. See, later part we will study why this inside that core, inner core is solid. After that solid part, that outer core is liquid. So that also we will see in the later part why that inner part is in solid state, and mantle that is in silicate, and crust is rocky. Now we'll study about the Mars. See, Mars is the fourth planet, that is the inner planet, and it is at a distance of 228 millions from the Sun, or 1.52 astronomical unit. And this is the second smallest planet. So its diameter is 6,778 kilometers. And it also Mars is also known as red planet. That we'll see why it is known as the red planet. So Mars is a rocky planet, also known as a terrestrial planet. Mars' solid surface has been altered by volcanoes, impacts, crustal movement, and atmospheric effects such as dust storm. So Mars, see, all planets have their own atmosphere. So Mars has a thin atmosphere made up of mostly of carbon dioxide, nitrogen, and argon. And Mars has two moons, Phobos and Deimos. See, why now we are searching for life possibility on Mars? Because there is a presence of ice. So Mars does not have water, but ice is present there. So that's why we are thinking that we can get water also. So that's why we are searching for the presence of life on the Mars. See, Mars, that inner core is made up of iron, nickel, and sulfur. So that inner core is iron, nickel, and sulfur, and same mantle is silicate. So how we say Earth, our mantle is silicate. So here also is mantle is silicate. And largest volcano located on the Mars, that is Olympus Mons. So in the Mercury also we study about that Montes. So remember that volcano name also. And on the Mars we have Olympus Mons. So this is also the about the height of Everest. So this is the same height of Everest. And in crust part, see, now in inner part, in core part also we have iron, nickel and sulfur. And in the crust part also, see here, this is Mars. So in this crust part also we have the iron. And since there is a small amount of presence of oxygen, so due to that what happens, that outer parts gets rusting. So due to that rusting, that we are seeing reddish in color, that rusting we are seeing. So due to that we are calling it as red planet. So Mars is also known as red planet. Okay. Now we'll see about the spacecraft sent to the Mars. So there were many spacecraft sent to Mars. So that is Mariner 1, Mariner 4, Viking 1. So this was sent by USSR. Then this one was sent by NASA. Then this one is sent, Viking 1 is sent by European Space Agency. Then Mars Express, that in 2003. Then Phoenix lander, this is sent by NASA. Then InSight, sent by NASA. And now we have sent it many, even our country also have sent it. So study about that one also. So that's all this was about the Mars. Now we'll study about the Jupiter. If anyone from the NDA class, you can leave now, because you have your class at 7 o'clock also. So anyone from NDA class, you can leave now. Today we'll finish about all planets, so that tomorrow we'll study about other things also. So now see, we'll see about the Jupiter. So Jupiter is the 5th planet. So this is the 5th planet, and it is 778 million kilometers away from the Sun, and it is the gas planet. Now we are studying about the outer planets, and all those outer planets are the gaseous planets. And Jupiter is atmosphere is mainly made up of hydrogen and helium. And Jupiter has 50 known moons, that is, and additional 70 moons we are waiting for confirmation. So totally it has 67 moons. And Jupiter also has a rings. See, we have studied that outer planets have rings also. So Jupiter has only one ring, so that is not that much important. But Saturn has many rings, so that is the most important. That we'll see in the later part. Now we'll see about the Jupiter. See, this is the gaseous, this is the planet, and why this is different color? Because all those are presence of gases, different gases. So that's why this is many colors. So this is surface is shown in many colors. And in this composition, we have the 75% hydrogen, 24% helium, and all other we have 1%, that ammonia, methane, water. And this Jupiter is 380 times than the Earth masses. And all other planets, it is 129 Earth masses. So remember about that Jupiter, why it is in different colors, because due to the presence of different types of gases. See, in Jupiter also, if questions comes, that the great red spot we are seeing, that is Jupiter, and it has the satellites, that is Ganymede, Europa, Callisto. About all the satellite, and also if you have that AFCAT slide, a study about all those important satellites that we have seen, so that you are clear through, because from the satellites also questions might come. And only that rotation period is 10 hours, and revolution period already we have mentioned there. And only one spacecraft has been sent there, that is Voyager, that is Voyager 1, that is in 1979. Okay, now we'll see about the Saturn. So this Saturn is also known as the ring planet, because it has ring system on its surface. So it is 1.4 billion kilometers away from the Earth, and Saturn takes 10.7 hours to rotate on its axis. And it is a gaseous planet, and it has the presence of, that atmosphere has the presence of hydrogen and helium, and it has total of 62 moons. And say Saturn has a ring system, and which is made up of 7 rings, so with several gaps. And that also we'll see, that all those rings also we'll see. See, Saturn is the less denser planet, that even if it put it on this water, it can float on the water. So it is very less denser planet. So remember, the Saturn is the very less denser planet which can float even on water also. And inner core is water, ice and rocky material, and it has no actual land mass, and it is metallic and molecular hydrogen. So see about rings, we'll see here. See, it has 7 group of rings. All those groups are arranged here. See, now inside this, take this as the surface of Saturn. So inside this we have the all those rings. All those rings are made from the eminence of comets, asteroid and moons. So all those rings, all those 7 rings are made for comets, asteroid and moons. That all those dust particles from all those, they are made up from that one. So now we'll study about the Uranus. So Uranus, see Uranus, one we left in the, see Venus and Uranus. Venus and this one, Uranus, both they rotate on its axis from east to west. Other all east to west. Other all planets rotate from west to east. Even our Earth also rotates from west to east. But whereas this Venus and Uranus, they rotate on their axis from east to west. And that's why because of that reason only, Uranus is also known as the blue planet. That we'll see the reason why. On its axis, it takes 17 hours to rotate, and it has the presence of fluid materials, that is water, methane, ammonia, and a small rocky core. So Uranus has an atmosphere made up of hydrogen, helium, and small amount of methane. So Uranus has 27 moons, and the important that characters spacecraft Uranus moons are named on the characters of the William Shakespeare and Alexander Pope. So that all those moons named are made on the based on the works of Shakespeare and Alexander Pope. And see, on the surface of Uranus, see now if we take this, if you see this, see all those planets are rotating on their axis on that 0-degree angle. But where is this Uranus planet? This is the Uranus planet. This is rotating on the angle of 97.7 degree angle. So this is rotating on the 97 degree angle. And this Uranus planet 80% is ice. So this is ice material. And because of presence of water, methane, see, since that sunlight is falling directly on its pole, that is eastern side and western side. So due to that, sorry, on the northern side, see directly it is falling on the northern side, since it is rotating here in this way, see, on the 97 degree. So on the northern side that directly falling, and because of that light presence of water, methane and ammonia, it is blue in color. So Uranus is also known as blue planet. So remember about that one. And why it is known as blue planet? That is because of presence of water, methane, ammonia, and because of that rotational, that is it is rotating on 97.97 degree. So because of that one. Now we'll study about the Neptune. So Neptune is the 8th planet and is the farthest planet from the solar system, and it is a sister planet to Uranus. So this is also known as Uranus sister planet, and its atmosphere is made of hydrogen, helium and methane, and it has 13 moons. That about moons also we will see. Triton is the highest moon of this planet. Triton is the highest moon, and Neptune core is the 15 times the size of the Earth, and made up of water, ice and silicate rocks. So that's all about Neptune, and it's known as, see, it's that moon. It has 13 moons, and that biggest moon is Triton. So that's all about all the planets. Tomorrow we'll study about moons and all other some little only left. So tomorrow we'll see. Actually at 7 o'clock we have the other class also, NDA class also. So today we'll finish up with this one, and tomorrow we'll study about latitude, longitude, and all those Earth's rotation, revolution, and how that time is known. So that everything we'll study tomorrow. So that's all for today. If any doubt, you can ask, or you can ask in the group also. You can ask on the personal message also. So anything, any doubt, anyone? Okay. So we'll finish up this class now. So tomorrow again we'll meet at the same time.